Namaskaram everyone and welcome back for an interesting session in mathematics. We have started with quadratic expressions yesterday and Madam USHA, PGT Mathematics from Velimala is well known to you now. I request Madam to continue with quadratic expressions. Over to you, ma'am.
Thank you, madam. Good afternoon, everyone. Let us continue with yesterday's topic, quadratic expressions. Yesterday, we have seen some concepts. Let us try to recall what we have seen yesterday. Roots of the quadratic equation, how will be the roots, and discriminant. Based on the discriminant, how we are going to judge the nature of the roots. Then relation between the coefficients and the roots of the quadratic equation. Then forming a quadratic equation when the roots are given. These are the concepts what we have discussed yesterday, right? So yesterday we have seen some problems, example problems based on each of these concepts. Not only that, we have seen some practice problems. Hope that you have practiced them, you have worked out, and maybe you are ready with your solutions also. Now, what are we going to learn today? We are going to learn equations reducible to quadratic form. That means if an equation is not in a quadratic form, then how to reduce it to quadratic form? That is a second degree equation in one single variable x, right? Which is in the form of ax square plus bx plus c. Then problems relating the equations reducible to quadratic form. Then finding the necessary and sufficient condition for quadratic equations which have the common root. That means if you are given with two quadratic equations and if it is given that the root, the two equations have got one common root, then how to check the condition, how to get the condition for the common root. Then finding the common root using the condition. And we will also see some properties of the quadratic equations. Yesterday we have seen ax square plus bx plus c equal to 0. With that we have seen the roots. Then based on discriminant we have discussed the nature of the roots. But if the value of the coefficients are changing, like suppose if they are equal to 0, not equal to 0, there are some specific cases that we will look into. Now let us solve a problem. X power 2 by 3 plus x power 1 by 3 minus 2 is equal to 0. Right? Now if you look at the power of each and every term, the powers are in fraction, in the form of a fraction, right? And you are not able to clearly say that this is a quadratic equation. But still, you can reduce this into a quadratic form by substituting certain terms, and we are trying to rearrange these terms in ax square plus bx plus c equal to 0 form. Now let us see the solution. You are given with x power 2 by 3 plus x power 1 by 3 minus 2 is equal to 0. Isn't it? This 2 by 3, we are writing it as 1 by 3 whole square. Now, if you can recollect the formulas in algebra, we have a power m whole power n is nothing but a power mn, isn't it? So, x power 1 by 3 into 2 is nothing but x power 2 by 3. So, this x power 2 by 3, I am writing it as x power 1 by 3 whole square. And I am not disturbing this x power 1 by 3. We are taking it as it is. Minus 2 is equal to 0. Right? Let us call it as equation number 1. Then we will try to substitute x is equal to 1 by 3 as k, some constant. When I do so, you will just substitute this k value in the place of x power 1 by 3 in equation 1. When you do that, just observe x power 1 by 3 is nothing but k whole square plus k minus 2 is equal to 0. Now look at this, k square plus k minus 2 is equal to 0. This is somewhat looking like your quadratic equation. Are you able to compare? This is a some x square plus bx plus c equal to 0 form. Here the variable what you are taking is k, right? Then we will try to factorize this, k square plus k minus 2 equal to 0. Is it that to find the value of k we have to go only with the factorization? No. You cannot, you need not stick on to one particular method. You can go with any of the methods which is comfortable to you. Here, since it is a very simple quadratic equation, we are just going for factorization. You will get it as k minus 1 into k plus 2 is equal to 0. Just observe this, k into k square, k into 2, 2k, minus k minus 2. 2k minus k, which is giving you plus k minus 2 is equal to 0. Then just will equate k minus 1 equal to 0 and k plus 2 is equal to 0. It leaves you k is equal to 1 or k is equal to 2. Now, if you can just observe your equation once again, your given equation is in the form of x, but we are finding out the value of k, isn't it? Now, this k value, when you substitute in equation number 2, then we will try to get the value of x by substitution. Now, substitute the value of k in equation 2, children. Then in the place of k, when I substitute 1, what is that I am going to get? X power 1 by 3 is equal to 1, isn't it? And if I substitute minus 2, it will be x power 1 by 3 is equal to minus 2. We'll do that. So first we will take x power 1 by 3 is equal to 1. Then since you have some fractional power, we will try to take the fractional power in the denominator you have 3. So we will take cubing on both sides. When we take cubing on both sides, x power 1 by 3 whole cube is equal to 1 cube. 1 cube is 1, right? So 1 by 3 and power 3, they get cancelled. Like right in the beginning I was mentioning, a power m whole power n is a power mn. So x power 3 by 3, which is nothing but x. X is equal to 1. Hope you got it. Then we will go for substitution of k is equal to minus 2. When you do that, x power 1 by 3 is equal to minus 2 you are getting. Then here again, since the denominator of your fractional power is 3, just to cancel this 3, we will take cubing on both sides. Then you will get x power 1 by 3 whole cube is equal to minus 2 whole cube. Now 3 and 3 here they get cancelled. You will get it as x minus cube is minus into minus into minus. So it gives you minus. And then 2 cube, which is nothing but 8. So you will be left with x is equal to minus 8. This is a simple problem, but by looking at a glance, maybe you will not feel that it is like a quadratic equation, but you can always reduce this type of equations into quadratic form by substituting certain terms in the equation. We'll see one more problem. We'll solve root of x by 1 minus x plus root of 1 minus x by x is equal to 13 by 6. This is a question. Now look at this. The expression which is under the root for both the terms, if you observe carefully, this is x by 1 minus x. This is 1 minus x by x. Exactly the reciprocal of the first one. And I can always write square root as power of 1 by 2, isn't it? Okay. Now you are given that root of x by 1 minus x plus root of 1 minus x by x is equal to 13 by 6. Then we'll say, we will just substitute root of x by 1 minus x is equal to k, like what we have taken previously. Here, the first term is equated to k. Then I can always write root of 1 minus x by x is equal to 1 by k. Just now I was telling x by 1 minus x and 1 minus x by x both are reciprocals, isn't it? So root of x by 1 minus x is equal to k. It is nothing but it is giving you root of 1 minus x by x is equal to 1 by k. Now these two values can be substituted in your equation 1. Your first term is k, your second term is 1 by k. That means your given equation, we are reducing it into some other form in terms of k. These two values we will be substituting in equation 1, children. So you will get k plus 1 by k is equal to 13 by 6. Now take LCM. When you take LCM, your LCM is k. Then k square plus 1 will be your numerator, which is equal to 13 by 6. Then we'll go for cross multiplication. 6k square plus 6 is equal to 13k. So you will have it as 6k square minus 13k. That 13k which is there on the other side of the equality, we are getting to the left hand side. So 6k square minus 13k plus 6 is equal to 0. Then this minus 13k, I'm just splitting it as minus 9k and minus 4k. Hope by this time you got the idea. I'm going for factorization method. From the first two terms, we will take 3k common. Then you will have it as 2k minus 3. And from the last two terms, I'm taking minus 2 common. Then you will get 2k minus 3. So 3k into 2k minus 3 minus 2 into 2k minus 3 is equal to 0. 3k minus 2 into 2k minus 3 is equal to 0. That means you are reducing 6k square minus 13k plus 6 is equal to 0 to 2 factors. That is 3k minus 2 into 2k minus 3 is equal to 0. So when I equate the first expression to 0, I will get k is equal to 2 by 3. And the second expression what you have, when you equate it to 0, you will get the value of k as 3 by 2. That means you are getting two values for k. What is k? K is one of the values which we have taken as substitution for one term in the given expression or given equation. So k plus 1 by k, plus 1 by k, we have k plus 1 by k, we have taken it is equal to 13 by 6 and we have got the value of k. This k I am just substituting here in this place. Root of x by 1 minus x is equal to k. Then root of x by 1 minus x is equal to, our first value was 2 by 3, isn't it? And the next value what we got is root of x minus 1 by x is equal to 3 by 2. So we are equating the expression which is under the root, what we have taken the substitution as k, and we have just substituted the value of k, that is 2 by 3 and 3 by 2 in this step. Then we will take squaring on both sides for these two equations so that we can cancel the square root of these two. So squaring on both sides, when we take, children, the square root here, it gets cancelled, isn't it? So you will be left with x by 1 minus x is equal to 2 by 3 whole square, which is nothing but 4 by 9. Then we'll go for cross multiplication. 9 into x is 9x. 4 into 1, 4 minus 4x. Now still further, 9x this 4x. I'm getting all the variables to my left hand side. So 9x plus 4x is equal to 4. So 9x plus 4x is 13x is equal to 4. Then x is equal to 4 by 13. Likewise, we'll go for the next, the other part of the problem, that is squaring on both sides of this equation also. You will get it as x by 1 minus x. Why so? Square root and the square, they get cancelled, isn't it? We are squaring on both sides. So here when we take square, 3 square is 9 and 2 square is 4. Then just go for cross multiplication. 4x is equal to 9 into 1, which is 9, minus 9 into x is 9x. Now here again we will get all the variables to one side, that means our left hand side, right? 4x, this 9x, it's coming this side, so plus 9x is equal to 9. 4x plus 9x is what? 13x, isn't it? So 13x is equal to 9. So x is equal to 9 by 13. Now, when we go to the previous slide, see, we have taken k value as 2 by 3 and 3 by 2. But what is the variable in our problem? Variable x, isn't it? It is you are not asked to calculate the value of k. You are asked to calculate the value of x. So our ultimate task, whatever substitution you take, is to find out x only. So after the substitution of value of k, we got these values. X is equal to 4 by 13 and x is equal to 9 by 13. So the required values which satisfy the equation will be 4 by 13 and 9 by 13. Now here are some practice problems, children. You can please take a screenshot and try out the problems on similar grounds. Now, if you can observe your 6th and 7th questions, like what we have seen in the example, the first term is root of x by x minus 3, isn't it? Whatever fraction you have for the first term, in the second term, it is reciprocated. So, if this term is taken as k, this term should be 1 by k. Likewise, in the next problem also, it is on similar grounds only. Right. Now we'll see another example. Find all numbers which exceed their square root by 12. The numbers which are exceeding their square root by 12. Now we'll go with the solution. First we will take the number which we have to calculate. We have to calculate that number, isn't it? But we don't know what is the number. So we will assume that our number is x. So let x be the number required. Then what is that he is saying? Square root of this number. Square root of this number is exceeding the number by 12. How much it is exceeding? 12 it is exceeding. That means for the square root, if you are adding 12, then it will be equal to the number what you are taking. Then we will rearrange this equation by getting this 12 to this side so that I can leave only the square root term on one of the sides. So x minus 12 is equal to root x. We will call it as equation number 1.
Hello. Hello.
Yes, Usha madam, we can hear you.
Yes, I'll continue in my mobile, madam.
Right.
Right, children. Now we have taken x minus 12 is equal to root x, isn't it? As our equation 1. Then when we take squaring on both sides, then you will have it as x minus 12 whole square is equal to x. Then x minus 12 is of the form a minus b whole square. Then if it is a minus b whole square, it is nothing but a square minus 2ab plus b square, isn't it? So x minus 12 whole square is nothing but x square minus 24x plus 144 is equal to root x, root x whole square. That root and square is getting cancelled. Then you will be left with x. Now get that x also to your left hand side. You will have it as x square minus 25x plus 144 is equal to 0. Now further, if you go for factorization, you will get it as x square minus 9x minus 16x plus 144 equal to 0. Now, from the first two, if you just take your terms carefully, from the first two terms, you can take x common, and from last two terms, you can take 16 common. Then you will get it as x minus 9 into x minus 16 equal to 0 as
Usha,
two
madam,
factors. Ma'am.
now the screen is being shared. Can you please repeat?
Okay. Okay, madam. Right, children. We will just continue with equation number 1. X minus 12 is equal to root x. This equation, we are taking squaring on both sides. Now, x minus 12 whole square is equal to root x whole square is x. So, x minus 12 whole square is equal to x. X minus 12 whole square is looking like a minus b whole square. A minus b whole square is a square minus 2ab plus a square minus 2ab plus b square, isn't it? So x square minus 2 into x into 12, which is nothing but minus 24x plus 12 square is nothing but 144 is equal to x. Now, the term x which is there on your right hand side, if we shift that to our left hand side, it becomes minus x. So minus 24x minus x gives you minus 25x, isn't it? So you will have it as x square minus 25x plus 144 is equal to 0. Then on simplification, on factorization, you have it as x square. That 25x, we are writing it as minus 9x minus 16x plus 144 is equal to 0. Then the terms, from the first two terms, you can take x common, and from the last two terms, minus 16 can be taken common, right? So you will have it as x minus 9 into x minus 16 equal to 0, isn't it? So from x minus 9 into x minus 16 equal to 0, the values of x which you are getting are 16 and 9. Now children, x equal to 16 and x equal to 9. We got two values, but these two values may satisfy the equation what you are given with, or the condition what you are given with. Sometimes they may not satisfy also. So we need to check whether x values are satisfying or not. Now let us go with case 1 where x is equal to 9. Now just observe, when x is equal to 9, you take your equation and just substitute your LHS part in your equation 1. In your equation 1, what is that you have? X minus 12 is equal to root x, isn't it? So what is your LHS? x minus 12. So instead of x, if you substitute 9, you will get 9 minus 12. Am I right? And then you have 9 minus 12 is nothing but minus 3. That is your LHS. Now go with RHS. In your RHS, in equation number 1, you have root x. What is root? What is the value you are taking for x? It is 9. So root 9 is nothing but 3. We got LHS as minus 3, but RHS is 3. So clearly we can say that LHS and RHS both are not equal. When both are not equal, then I can definitely say that the value x is equal to 9 is not satisfying the given condition. Then we will take case 2. Our case 2 is x is equal to 16, right? So when x is equal to 16, when you take your equation is x minus 12 is equal to root x. So your x value is 16. 16 minus 12. 16 minus 12 is nothing but 4. 16 minus 12 is nothing but 4. Your LHS is 4. Take your RHS. RHS is root x. Instead of x, you just substitute 16. Root 16 is what? Root 16 is nothing but 4. Right? So your LHS and RHS are equal. That means the case 1 where you have gone with substitution of x is equal to 9 is not satisfying the given condition, but case 2 x is equal to 16 is satisfying. Therefore the number which is required or the number which satisfies the given condition is 16. That means we can discard the value x is equal to 9. Right. We will go with one more problem, children. The problem is solve x power 2 by 4. Solve 2x power 4 plus x cube minus 11x square plus x plus 12 equal to 0. Right? Now, if you can observe your equation carefully, equation is of degree 4. Now, at a glance, when you look at that, it is not looking like quadratic equation, but still we can say that we can reduce this equation into quadratic form. How is that we are going to do it? We will divide the total equation with x square on both sides. We will divide the equation with x square on both sides. When we do so, look at your equation 2x power 4. That means each and every term which is there on your left hand side, we will take it with the denominator as x square. So 2x power 4 by x square plus x cube by x square minus 11 x square by x square plus x by x square plus 2 by x square is equal to 0. Now this implies, now look at this, look at your first term, x power 4 by x square leaves the answer as x square, isn't it? So you will get it as 2x square plus x cube by x square is x. So you have x square by x square, they get cancelled, then you will be left with only 11. X by x square is 1 by x, 2 by x square remains as it is. So you will be getting it as 2x square plus x minus 11 plus 1 by x plus 2 by x square equal to 0. Right. So we will try to rearrange the terms. We will try to rearrange the terms what we got. 2x square and the last term 2 by x square. We will take it in one bracket, children. 2 into x square plus 1 by x square plus the second term from your left hand side and the second term from your right hand side. We will rearrange them in the second bracket as x plus 1 by x. And minus 11 remains as it is. So the equation will be 2 into x square plus 1 by x square plus x plus 1 by x minus 11 is equal to 0. We will call it as equation number 1. Now, I think you got some idea how to solve this problem, like what we have done in our previous problems, isn't it? So you have it as x square plus 1 by x square in one bracket, x plus 1 by x. We will take x plus 1 by x is equal to k as the substitution. Now, when we do that, we will take squaring on both sides, children. Then you will be getting x square plus 1 by x square plus 2 into x into 1 by x is equal to k square. Why? Because x plus 1 by x whole square is nothing but a plus b whole square, right? Okay. Then in this equation, x and 1 by x in the last term of your left hand side, they get cancelled. And you will be left with 2. So x square plus 1 by x square plus 2 is equal to k square. So x square plus 1 by x square, we will take 2 to the other side. It becomes k square minus 2. Let us take this as equation number 3. Now look at your first, second and third equations carefully. In the first equation, your first bracket is x square plus 1 by x square that we have calculated, isn't it? And x plus 1 by x, we are taking the substitution as k that we have. So these two values can be substituted. These two values can be substituted in equation number 1. So after substitution, you are getting it as 2 into k square minus 2 plus k minus 11 is equal to 0. Right. Now we will try to expand this. We will try to expand this by multiplying 2 into k square minus 2. We will have it as 2k square minus 4 plus k minus 11 is equal to 0. So you have it as 2k square plus k minus 15 is equal to 0. We are just simplifying it. Minus 4 minus 11 is giving you minus 15. So 2k square plus k minus 15 equal to 0. Now, is it looking like a quadratic equation? Yes, isn't it? And it is in terms of what? In terms of k. So now we will try to simplify this or factorize this by taking k as plus 6k and minus 5k. 2k square plus 6k minus 5k minus 15 equal to 0. From the first two terms, let us take 2k common. Then you will have it as k plus 3. Then take minus 5 common from the last two terms on your left hand side. You will have it as minus 5 into k plus 3 equal to 0. Then you will be left with k plus 3 into 2k minus 5 is equal to 0. So the values of k what you are getting are minus 3 and 5 by 2. Now still we didn't get our answer. We got only the value of k. We need to find out the value of x, isn't it? Our ultimate task is to find out the value of x. Now let us take x is equal to minus 3. When x is equal to minus 3, x plus 1 by x will be equal to minus 3. Then if you just simplify it by taking your LCM will be x. Then you will have it as x square plus 1 by x is equal to minus 3. Then go for cross multiplication. You will get x square minus 3x plus x square plus 1 on one side and minus 3 into x on the other side. So that minus 3x we will get to this side. You will have it as x square plus 3x plus 1 equal to 0. Now you can also solve this by factorization method, but here since the b square minus 4ac value, yesterday when I was discussing about nature of the roots, we were talking about perfect square and not a perfect square part. Hope you remember that. Now by looking at b square minus 4ac value, I can definitely say that what you are getting b square minus 4ac is not a perfect square. So you are getting it as an irrational root. Hope you got that. So that is the reason why, just for my convenience, I'm making use of the formula to calculate the roots of this equation. So x is equal to minus 3 plus or minus root of 3 square minus 4 into 1 divided by 2 into 1. Then 3 square is 9 minus 4. 9 minus 4 is 5. Root 5 you are getting, children. So you are getting it as x is equal to minus 3 plus or minus root 5 by 2. Now just observe the value x. What type of value you are getting? It is a surd, isn't it? That means it is a irrational value what you are getting. Yesterday I was mentioning a point. Always irrational roots occur in pairs. What do I mean when I say pairs? Pairs, they are nothing but conjugates. So the values what you have here are minus 3 plus root 5 by 2 and minus 3 minus root 5 by 2. Now the next case what we look into is k is equal to 5 by 2. When k is equal to 5 by 2, x plus 1 by x is equal to 5 by 2. This implies x square plus 1 by x is 5 by 2. We'll go for cross multiplication. Then you will have it as 2x square plus 2 is equal to 5x. Then you will have it as 2x square minus 5x plus 2 is equal to 0. Here again, when you calculate b square minus 4ac value, it is not a perfect square. So you are getting irrational roots. Now since you are getting irrational roots, you can always comfort yourself by making use of the formula, that is minus b plus or minus root of b square minus 4ac by 2a. Right. So when I substitute that, you will have it as minus of minus 5 plus or minus root of minus 5 whole square minus 4 into 2 into 2 divided by 2 into 2. Minus 5 whole square is nothing but 25 minus 4 into 4, which is nothing but 16. Right. So 25 minus 16, which is nothing but root 9. Root 9 is 3. So 5 plus or minus 3 by 4. 5 plus or minus 3 by 4. 5 plus 3 is 8. 8 by 4 is 2. And 5 minus 3, which is nothing but 2. 2 by 4, which is nothing but 1 by 2. So x value, we got it as 2 and 1 by 2. Now, let us recollect our original equation, children. It is of degree 4. Hope you got it. When the power is 4, you can expect 4 roots, 4 values which satisfy the equation. So the values what you have got are minus Right. We got x is equal to -3 plus or minus root 5 by 2. That means two values here. And the other two values are, from this case, k is equal to 5 by 2. We got it as 2 and 1 by 2. So totally 4 values we have calculated for x in this equation. Since the equation is of fourth degree, you are getting 4 roots. Now here is a small practice work for you. Now just look at your problems, children, practice problems. In the bracket you have x plus 1 by x, isn't it? Now comfortably you can just take that as k and start doing your problem. Now the problem what we have taken as an example, it is not simplified into this form. We have divided it by x square and got that into this form. But here it is more simplified one. So directly 8th question, you can take x plus 1 by x is equal to k. And for 9th question, whatever method I have taken in the example, like dividing with x square, you can go. Next, the next concept is common roots. Now, when you are when do you take the word common? When you have something to compare, isn't it? Now we are talking about common root, and in this topic quadratic equations. So you can compare only when you have one or more, two or more equations. So here we will take a case of two quadratic equations. Now the two quadratic equations given are a1x square plus b1x plus c1 equal to 0 and a2x square plus b2x plus c2 equal to 0 as quadratic equations. So when you have two equations, then only you can compare, right? Now the condition what he says is both of them have got common root. Common root means what? You have one value which satisfies both the equations. The value, one of the values in this, or sometimes the two values what you are getting also may match. But he says it has got common root. So one value may be common. Sometimes whatever roots you are getting for the first one may be matching with the next, the other one also, provided A1, B1, C1 and A2, B2, C2 are equal in that case. Okay. So here we will take all A1, B1, C1, A2, B2, C2 values as distinct values. In that case, these two equations will have a common root when they satisfy this particular condition. What is this condition? C1A2 minus C2A1 whole square is equal to A1B2 minus A2B1 into B1C2 minus B2C1. Now, based on this, we will solve one problem. The problem is if x square plus 4ax plus 3 is equal to 0 and 2x square plus 3ax minus 9 equal to 0 have a common root, then he's asking you to find out the value of a. He is saying that these two equations have got common root. Now, when they have common root, they have to satisfy this condition, isn't it? So we will try to compare the coefficients of these two quadratic equations and we will write the values of A1, B1, C1 and A2, B2, C2. When we do that, you will get it as A1 is equal to 1, B1 is equal to 4a, C1 is equal to 3, and here from A2 it is 2, B2 it is 3a, that is from this second equation, and C2 value you are getting it as minus 9. Then you just substitute in this condition. C1 is 3, isn't it? So 3 into 2 minus 9 into 1. Minus 9 is C2. Whole square is equal to 1 into 3a minus 2 into 4a into 4a into minus 9 minus 3a into 3. Just I want you to pay little more attention when you substitute, children. Generally, when we go for substitutions, many mistakes creep in, isn't it? So be careful. Try to write these coefficients first before you go for the substitution. Then 3 into 2, 6, minus into minus plus, 9 into 1 is 9. So 6 plus 9, which is nothing but 15. 15 whole square is nothing but 225. Then here you have 1 into 3a, which is 3a. 2 into 4a is nothing but 8a. 3a minus 8a is nothing but minus 5a. Right. And the next bracket you have 4a minus 9, which is nothing but minus 36a. And 3 into 3, 9a. So 36a minus 9a is nothing but minus 45a. So you are left with 225 is equal to minus 5a into minus 45a. 45 into 5, which is nothing but 225. Minus into minus is plus a square. So 225 is nothing but 225a square. So you are getting a square is equal to 1. When a square is equal to 1, you are getting it as a is equal to plus or minus 1. Now a value is 1 and a value is a is also taking minus 1. So we will try to see both the cases. When a is equal to 1, what happens? And when a is equal to minus 1, what happens? And what type of common roots you are getting, we will observe. Now your case 1, you have a is equal to 1. When a is equal to 1, in the first equation, where you have 4ax, in the place of a, we will substitute 1. So you will get it as x square plus 4x plus 3 equal to 0. And your second equation is 2x square plus 3ax minus 9. Instead of a, when I substitute 1, you will get it as 2x square plus 3x minus 9 is equal to 0. Then we will go for simplification of the first one by factorization. You will have it as, see that 4x, I'm splitting it as x plus 3x. Then you have it as x square plus x plus 3x is equal to 3. X square plus x plus 3x plus 3 equal to 0. From the first two terms, you will take x common, and the last two terms, you will take 3 common. Then you will be left with x plus 3 into x plus 1 equal to 0. That means you are getting 2 factors. Now x plus 1 will give you x is equal to minus 1 and x plus 3 gives you minus 3. And likewise, we will go for simplification of the second equation. Instead of this 3x in between, we are trying to write it as plus 6x minus 3x. Plus 6x minus 3x is nothing but plus 3x. Right? Now, on simplification, after simplifying, if you take 2x common from first two terms and minus 3 common from the last two terms, you will be left with 2x minus 3 into x plus 3 is equal to 0. So you will be left with x is equal to minus 3 and 3 by 2 as your answers. Now just observe your x values, children. X value here is minus 1 and minus 3. Here it is minus 3 and 3 by 2. Can you find? Are you able to find any common root over here? Yes, that is minus 3. So when a is equal to 1, you are getting a common root as minus 3. Now we will let us look into second case when a is equal to minus 1. When a is equal to minus 1, your first equation becomes x square minus 4x plus 3 is equal to 0. And the second equation, it will be 2x square minus 3x minus 9 is equal to 0. Let us simplify our first equation. This minus 4x, I am writing it as minus x minus 3x. What am I doing here? I am trying to factorize. isn't it? So from the first two terms, I can take x common, and from these two terms, I can take minus 3 common. So the factors what you are getting are x minus 1 and x minus 3 equal to 0. So value of x will be 1 and 3. Let us take the second equation. This minus 3x which is there, I tried to take it as minus 6x plus 3x. Right. So from the first two terms, I can take 2x common. From the last two terms, I can take 3 common. Then the factors what you are getting will be 2x plus 3 into x minus 3 is equal to 0. So x is equal to 3 and minus 3 by 2. Now here again, if you observe carefully the values of x in both the equations, you can find some common root, isn't it? The common root is 3. Now in both the cases, whether a is equal to 1 or minus 1, you are able to get a common root. In the first case, the common root was minus 3, and in the second case, the common root is 3. Right. We'll see one more problem based on this. Now, if the equation x square plus ax plus b equal to 0 and x square plus 6x plus cx plus d equal to 0. Now, these two are quadratic equations in variable x, right? So, he has given that they have a common root, and not only common root, you are given with one more additional condition, that is your first equation has got equal roots. Now, when do you get equal roots for a quadratic equation? Yes, you will get equal roots when the discriminant is equal to 0. That is, delta is equal to 0. Right. So let us take the given equations. You are given with x square plus ax plus b equal to 0. Let us call it as equation 1. And the second equation, you have it as x square plus cx plus d equal to 0. Right? We'll call it as equation number 2. Then he has given the condition that first equation has got equal roots. When it has got equal roots, your delta should be equal to 0. What is delta? When you have the quadratic equation as ax square plus bx plus c equal to 0, your delta value is nothing but b square minus 4ac. Here your b value is a in this equation, isn't it? So we will just substitute in that formula. Then we'll get it as a square minus 4 into 1 into b equal to 0. Then a square minus 4b equal to 0. That minus 4b, if you're sending to the other side, you will get it as a square is equal to 4b. We will take this as equation number 3. We are going to make use of this condition to get to prove that 2 into b plus d is equal to ac. Now, you are given that x square plus ax plus b equal to 0 has got an equal root, isn't it? When a quadratic equation has got an equal root, yesterday we have seen that equal root will be equal to minus b by 2a. Now instead of b, you have a, right, in our first equation. So it is minus a by 2 into 1. Minus a by 2 into 1 is nothing but minus a by 2. Now, the given equations 1 and 2, they have got a common root, children. And let us come to the previous point itself. We said the first equation has got equal root. See, for any quadratic equations, what are the maximum number of roots you have? 2 roots. And we said the equal root is minus a by 2. That means the other root is also minus a by 2. So the 2 roots what you have for the first equation are a by 2, minus a by 2, comma a by 2. That means it indirectly says that minus a by 2 should be a common root for the second equation also. So we'll say the given equations 1 and 2 have a common root, and the common root will be x is equal to minus a by 2. We will substitute this in the second equation. What is this? X is equal to minus a by 2. Now, instead of x, wherever you have x, you just substitute minus a by 2. Then you will have it as minus a by 2 whole square plus c into minus a by 2 plus d equal to 0. Now, simplify this. You will get it as minus a whole square is a square. 2 square is nothing but 4. And this is minus into plus, which is minus c into a, that is ac by 2. So, a square by 4 minus ac by 2 plus d equal to 0. Then take the LCM. Your LCM, before we take LCM, instead of a square, we will substitute it as 4b. Now, your equation 3 in the previous slide, what we have seen, we got a condition from the first equation, isn't it? A square is equal to 4b. That condition we are substituting here in the place of a square. So 4b by 4. This 4 and 4, they get cancelled. You will be left with b. Then you have ac by 2 as it is and d. Then this b plus d I will keep on one side, and I'm just moving this ac by 2 to the other side. Okay. Now, see, you are getting this equation because a square is equal to 4b. This is from equation number 3. So you need to quote that. Whenever you are taking some reference, that reference should be taken just beside the step. Right, we'll go for cross multiplication, children. So you will have it as 2 into b plus d is equal to ac. This is the condition what is required. So based on this common roots condition, we have seen 2 different problems. Based on this, you will have some practice questions. Please take a screenshot. Now, let us look into some properties of quadratic equations. See, right from the beginning of the session, we were talking different properties. Now, when I started with the definition of a quadratic equation, we have started with a condition saying that any quadratic equation should have a not equal to 0. That is, the coefficient of x square should not be equal to 0. Isn't it? That is the prerequisite for any quadratic equation, because if x square coefficient is equal to 0, then you will not have a second degree or a quadratic equation. It becomes a linear equation. Likewise, we have got some properties for quadratic equation. Now, if you consider ax square plus bx plus c equal to 0 as your quadratic equation, and suppose you have a and c not equal to 0, that means they are non-zero numbers. They are simply numbers. But b, the value of b is 0. So in ax square plus bx plus c equal to 0, when you put b equal to 0, that x term vanishes. Hope you have observed this. Right. So when we substitute b equal to 0, you are getting it as ax square plus c equal to 0. So this ax square plus c equal to 0, we call it as a proper quadratic equation. Now for this proper quadratic equation, when we take alpha and beta as the roots, then let us see how will be sum of the roots. What is the formula for sum of the roots? It is minus b by a. When b is 0, b itself is not there. It has disappeared from this equation, isn't it? Why? Because b is 0. When b is 0, automatically sum of the roots will be 0. Then, is it affecting product of the roots? No, because it is not involving the value of b. So, alpha into beta is nothing but c by a. So, for this ax square plus c equal to 0, when we consider alpha and beta as the roots, sum of the roots is 0, product of the roots is c by a, and your delta value, what is delta? B square minus 4ac. Since b is 0, you will not have that term. You will be left with delta is equal to minus 4ac. This 4ac value, definitely it will not be equal to 0. Can you tell me why? Why it will not be equal to 0? Because a and c are not equal to 0. Now, in this case, you will have the roots of the equation to be same absolute value. Same absolute value when you take modulus. Now, like for example, if you take 3 and minus 3 in modulus, you will be left with 3. So 3 and minus 3, we call them as same absolute values. Now, if alpha and beta are the roots of the quadratic equation, this is also a quadratic equation, children. Ax square plus bx plus a equal to 0. Generally, we take the constant as c, but in the place of constant, here you are taking it as a. And the condition which we are imposing on this equation is a not equal to 0. Then, what happens to product of the roots? What is product of the roots? Alpha into beta, isn't it? Alpha into beta is nothing but c by a. But what is there instead of c? Instead of c, you have it as a. So a by a is nothing but 1. So you are getting it as alpha into beta is equal to 1. Now observe this. When you take alpha into beta equal to 1, then if I want to calculate alpha value, I should move this beta to the other side, right? So alpha will be equal to 1 by beta. Now suppose if I want to calculate beta, then I should move this alpha to the other side. So beta will be equal to 1 by alpha. So neither alpha nor beta, they become 0 in this case. And alpha value will be 1 by beta and beta is nothing but 1 by alpha. What do you understand from these two values? Each root, whatever roots you have, they are reciprocal to one another. Now, if the signs of a not equal to 0 and c not equal to 0 in the quadratic equation, ax square plus bx plus c equal to 0 are same. Now let us try to see what exactly is the meaning of this sentence till here. Now you have a quadratic equation. A is not equal to 0. C is not equal to 0. Okay, they are non-zero values. Now he says signs of A and C. Now they are same. That means if A is positive, C is also positive. And A is negative, C is also negative. So if the signs of these two values are same and these two values are not equal to 0, then the product of the roots will be positive. What is product of the roots? Product of the roots is nothing but c by a, isn't it? Product of the roots is nothing but c by a. C is positive, A is positive. Then it gives a positive value. Now suppose if C is negative and A is negative, then that negative and negative cancels themselves and it leads to a positive value. So when signs of A and C, they are same and both are non-zero values, then product of the roots will be always positive. And for this type of equation with a condition, you will get the roots to be real and they will have same sign. Then the next case is if A and C have different signs. That means A and C are non-zero, but they have different signs. Suppose if A is positive, C is negative. Okay, or either ways, or vice versa. Then product of the roots will be negative. Why it is happening so? If we have alpha beta is equal to C by A. Let us take C is negative. Negative by positive, it gives a negative value, isn't it? Now, the other case, if A is negative, then positive by negative is also negative. So if A and C have different signs, the roots will be real and will have different signs. Now, madam, any queries?
No, Shastri madam. Students haven't posed any queries.
Okay.
Thank you, Usha madam, for a wonderful session on quadratic expressions. With an introduction to the change in the signs of the roots. The roots will be positive, negative. I hope you can, we will go ahead and learn how the signs change in the next class. Thank you. Thank you, students.